Hello my dear champions, welcome back to physics class. In today's class, let us make sure that our curiosity has maximum acceleration and minimum friction, all thanks to Newton's laws. Okay, so let us start with the applications of Newton's laws in today's class. So here we begin with the applications of Newton's laws. So for this, let us first of all consider a book lying on a table. So let us consider a book lying on a table. So in order to make this book move, we need to apply a force. A force can be applied directly on the book to set this book into motion. Direct application of force. Even the force can be applied indirectly. How indirectly means? Suppose for the same book, if we have attached a string is being attached to the book, something like this. Okay, so and instead of applying the force directly on the book, we have applied the force on this particular string. So when force is applied on this particular string, not directly on the book, so what possibilities are there? Let us try to see and understand. If this force is being applied on the book somewhere at the edge of the book, and on this string the force is being applied perpendicular to this direction of the book, then what happens? As the string is attached to the edge of the book and the force is being applied perpendicularly, no doubt the book will be tilted. The book will be tilted vertically upwards, and during the tilting the book will be based on the second edge of the book. Similarly, if we apply the force somewhere here, if the same force is applied with the help of a string on the other edge of a book, the book will be tilted on the first edge of the book. So two cases. And the same case, if the same force is being applied at the midpoint of the book, then the book will be directly lifted upwards without tilting. So three possibilities we have observed till far. First one, without the help of a string, direct application of force on the book. So that is a direct method of application of force. The second method, we have applied the force by attaching a string onto the book, and we have applied force on the string, and it matters where the string is being attached. Okay, so if the string is attached at the one edge of the book and it is lifted vertically, then the force is applied perpendicularly, the book will be tilted at the other side. If the same force with the help of a string is applied at the midpoint of the book, then the book is directly lifted upwards. So three cases are possible. So here, to understand the applications of Newton's laws, first of all, how much force is being applied, that is, the magnitude of force applied matters. Similarly, the direction in which the force is being applied, whether towards the right, left, upward or downward. So direction of the application of force also matters. And the point of application of force on, okay children. So from this, we can conclude that three factors determine the effect of force that has been applied on the body. The first one, the magnitude of the force applied. Second one, the direction in which the force is being applied. And third one, the point of application of forces. So based on this, the forces are generally classified into three types. So types of forces. If you consider the types of forces, we have three types of forces. One is contact force, the other is non-contact force, and the third one is attachment to another body. So first of all, if you consider the contact force, so these forces are possible while without any contacting, so without any touching of the objects. For example, gravitational force. Suppose if you consider a pen, and if simply a pen is being released without any application of force, simply it is being left left over, then there will be some acceleration due to gravity acting on the body, and there is no contact, there is no direct contact of this acceleration due to gravity on the object. Okay, so these type of forces is a non-contacting forces. Okay, so two types of forces will come into play. One is a contact force, the other is non-contact forces. So gravitational, not only acceleration due to gravity, gravitational force between any two objects or any two masses, okay, comes under the non-contact forces. Similarly, the electrostatic force acting between any two charges, positive charge, negative charge, so on and so forth, the electrostatic force of repulsion or attraction between any two charges comes into this non-contact forces. Whereas during the contact forces, to make you understand the contact forces, you have like normal reaction, frictional forces, and many such forces come into play. So in order to understand the contact forces, we need to consider a small basic example. So if you consider an object which is lying on some horizontal surface, okay, so this object, if a force is being applied on this directly, a force is being applied on the body will be set into acceleration, the body starts moving. Okay, so this is an example of a contact force. Similarly, if you consider two different bodies, like on the horizontal surface, a body A is being considered and another body B is being considered, something like this. Two different bodies are kept in contact like this. Okay, so in this case, if you consider only one particular object, if you consider, means no doubt the whole mass is supposed to be m, the whole weight of the body is acting downwards. Okay, so according to Newton's third law, for every action there is an equal and opposite reaction. If the weight is supposed to be acting downwards, there must be equal and opposite reaction force that must be balancing that weight, and that force is called as your normal reaction, may be indicated with N. Mostly it is indicated with N, where N indicates your normal reaction. Okay, suppose if instead of single body, if you would have considered two different bodies, okay, so this is one body and this is another body. Let us name this as A and the other, let us name it as some V. Okay, and if some force is being applied on this first body, then as the two bodies are kept in contact, then there must be some frictional force comes into play. Okay, apart from this, no doubt the weight of the body A must be acting, weight of the body A is acting downwards. Suppose the mass of the first body is m1 and the second body is m2. So weight of the body m1g is acting downwards and the B is exerting some weight of the body. Weight of the body A is acting downwards. As a result, some upward reaction must be there. So B is exerting some opposing force on that. This is normal reaction acting on one. Okay. And similarly, if you consider as the two bodies are in contact, no doubt the weight of the body B, M2 mass, so M2G, acting downwards, whereas this normal reaction must be acting upwards. Okay, but if you consider only this particular case, this will exert normal reaction in the upward direction and this will exert the normal reaction in the downward. So whenever you consider two different bodies in contact and the force is being applied on any body, then in the area of the contacting surface there must be another force that comes into play, that is called as your frictional force. So this is a force applied and this must be a frictional force. Okay children, well the same will be happening if the force is applied, the same force is applied instead of this. If the same force is applied here in this direction, then the frictional force will be acting in the opposite direction. So these are the examples of contacting forces. Okay, children. Well, now moving to the attachment to another body. So, how the bodies are being attached. This is only regarding two surfaces in contact. When force is applied on one body, because of the contacting surfaces, okay, there must be some frictional force that comes into play. Okay. Whereas, if you consider regarding the attachment of another bodies, attachment means any two or more than two bodies are connected with the help of strings or springs. What are they, children? They are connected by the help of strings or springs. In this case, the force that is acting mostly depends on the factor F proportional to X or F is equals to Kx. So it depends on the factor that F is equals to Kx, whether it is connected with the help of a string or a spring. Okay, so let us try to discuss the same in detail. So children, attachment to another bodies. Two bodies can be attached in any direction, something like this. So let us try to understand the attachment of one body with another body. So two or more bodies can be connected with the help of strings or a spring. Okay. So whenever two or more bodies are connected with the help of a string or springs, then the force or tension will come into play, and it is depends on the factor that F is equals to Kx. To understand this in detail, let us consider a basic example. Here again, three conditions comes into play. First one, if you consider that first case, the string is inextensible. Instead, string and spring both are same conditions, children. So instead of using the two terms, I am using string altogether. So if the string happens to be inextensible, so what is the meaning of inextensible? The length of the string remains same. It is not extendable. Okay. So if the string happens to be inextensible, then the magnitude of acceleration, suppose a body of mass m is attached to another body of mass m, then suppose if it is applied, some force is applied here, then no doubt the body will move with some acceleration. The other body will also move with the same acceleration. So that means if the string is not extensible, then acceleration of both the bodies will be same. So either this example you can consider, or even you can consider another example with the help of a pulley. This is mass m and here some mass m. Two masses we have considered. Suppose, as I said, that the string is inextensible. Then suppose if one object is moving with some acceleration, say A, then if it is coming downwards, no doubt it must be going upwards. Then the acceleration in both the strings will be, acceleration for both the masses will be same if and only if the string is inextensible. And also remember that the tension in the string remains same. What is that, children? The tension in the string remains same. The tension means, suppose if T tension is acting here, then throughout the string, the tension will remain same. So here T and here also T. Is that case clear, children? If the string is inextensible, and then the acceleration of both the masses will be same. And one more thing I would like to add upon, children, if the string is inextensible as well as massless, no mass. If the string is inextensible and massless, then the tension in the string throughout the string will remain same. So here at each and every point of the string remains same. Is that clear? Well, now moving to the second point. What happens if the string is having mass? There must be some differences we would like to observe. Okay, if the string is having mass, then the tension at each and every point may not be same. Okay, well, tension is different at different points. So massless means tension will be same. Tension is same. If the string is having mass, then tension will be different at different places. This you need to understand properly, children. I hope this is clear. String inextensible, acceleration of both the blocks will be same. String, whether it is inextensible, and string is massless. If the string is massless, tension is same at every point. But string is having mass, tension will be different at different points. So for this, let us try to understand with a proper example. So again, let us consider a table to which a pulley is being attached and masses are kept here. First mass, say M, attached to the another mass, say capital M, with the help of a string. Case 1, if you observe, what I said was the string is massless. If the string is massless, then the tension in the string will be same. And if the string is inextensible, then acceleration of both the blocks will be same. Okay, acceleration of both the blocks will be same. So these two things I have explained, whether with the help of this diagram, this picture, or the other picture. 3 different cases, but the same condition. Now I would like to continue with the same table to which a pulley is being attached. Again, take a body of mass M with the help of a string. Another body of mass M is being attached. Let us suppose that all the strings are inextensible, then the acceleration in the complete system will be same. But here, first example, I consider the string as massless, and now if I consider for the second example, string is having some mass, the string is having some mass, then what happens means the tension in the string must be different. Okay, so here tension at each and every point in the string will be here, 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 here. Each and every point the tension will be say different. Why? Because the string is having mass, because of the mass that is present and the weight that is been acting. Here if you consider T1 here T2, here T3, here T4, here T5. So if the string is having mass, tension at different points will be different. This thing you need to understand. Now one more example, children. Again the same table to which a mass M is attached to another mass capital M with the help of a string, and in this case again, case 3, the string happens to be massless. The string is massless. In case of a massless string, but there is a friction between the pulley and the string. Friction between pulley and string. Here, so friction is there between the two strings, between the string and the pulley, some friction is there. So in that case, you need to understand that the tension in one part of the string will be different to that of the tension in the other part of the string. That means if you suppose that the tension in this first string be some T1. Okay, so here whatever you consider, here if you consider the tension as T1, then the tension in the next part of the string will be different, something like this. Here some T2 and here also T2. So one portion of the string is having some different tension, the other portion of the string is having different tension, because whenever you consider a massless string but a friction acting between the pulley and the string. So these are the things you need to remember, the 3 things you need to remember properly, children. Massless and inextensible, same acceleration, same tension. Massless but friction between the pulley and the string, then tension for one portion of the string is different to the another portion of the string. String is now having mass. These two examples are massless strings, and this is an example of a mass string. So whenever you consider a string having some mass, then you need to remember that the tension at different positions of the string will be different. Okay.